there, thank you for joining us. This is the rates video. In this video, I will teach you to solve the rate problems. We will take a look at the equation to use, review steps to solving problems with this equation, and practice with some more problems. So, rates express a unit or ratio. A rate can express anything. You have a rate that states that you eat 2 chicken nuggets for every 3 french fries in a meal. It can literally just be about anything. Oftentimes, the unit will express a change over time. For example, 5 miles per hour. This is also considered a rate, as long as it is comparing something. Basically, the point is that it's easy to identify a rate question because it's giving a change over time. Rate questions can be solved just like proportion questions, but some special types of rate questions require unit conversion, and that's what we're going to look at, okay? So unit conversions are pretty easy. They're done with multiplying some fractions. We're going to get it, and I will go over it with you. Jennifer drove for 3 hours at 62 miles per hour. How many miles did Jennifer drive? Go ahead and give that question a try. Alright, how'd it go? I hope you got it. If not, don't worry, I'm going to go over it step by step. So the first thing we're going to do is identify that rate, alright? So the rate is 62 miles per hour. How do you know? Well, because it's giving us a change over time. It's telling us that Jennifer is traveling 62 miles per every hour, okay? And it also gives us, the question also gives us a time frame, 3 hours. The way we make this work is that we want to manipulate our rate so that we can cancel things out. I know that sounds kind of I know that sounds kind of funny, but let me show you how to do it and hopefully it'll make a little more sense. So let's start off by writing what our rate is. We have 62 miles for every 1 hour. Okay? We know that she traveled for 3 hours. So we're actually going to multiply this. We're going to put it over 1 just so that we have fractions. It's not a big deal. So this works. And the reason this works is because the hour and the hours cancel each other out. Essentially, what you want to do is cancel out units, okay? So we want to cancel out these units, and that's how we know we're doing this correctly. Sometimes when you multiply, you'll realize, I got to divide this instead. And we know this by making sure that the units cancel each other out. I hope that makes sense. So 62 times 3, the unit that's left over is miles. And that's how we know we did it correctly, because that's what the question is asking us for, the number of miles. So 62 times 3, let's multiply that. 3 times 2 is 6, 3 times 6 is 18. So we know that Jennifer traveled 186 miles. I'm going to review this again to make sure you understand. When we're working with a rate, we write the rate as a change over time. Or it could be like a ratio. Basically, you're comparing something to another thing. Then what we want to do is we multiply it to whatever our given is, our other given. And we're going to manipulate these so that what we're doing is we're canceling out our units. That's what we want to do. If we cancel out the units and we're left with a unit or the answer that we want, then that works and we got it right. That's how we know we did this correctly. By comparing or setting up rates like this, what we're doing is we're realizing what we have to do, what operation we have to perform to be able to get the answer. Basically, we realize, okay, we have to do 62 times 3 to get 186 miles. Go ahead and give that a try with the next one, and hopefully it'll work a little bit better. If not, don't worry. We have a couple of questions for us to work together, and you're going to get it. Okay? Go ahead and take a look at the next question. All right, the question is, Ernesto drove for 5 hours at 35 miles per hour. If his car used 1 gallon for every 25 miles, how many gallons of gasoline did Ernesto use? Good luck. Give it a try. Welcome back. I hope you got it. If not, don't panic. We're going to go over it together, okay? So this one was a little more complicated because we have 2 rates in this question. So the first rate is 35 miles per hour. The second rate is 25 miles per gallon. So we're going to manipulate these, remember, so that we can end up with what we want. All right, so our givens are 5 hours, 35 miles per hour, 25 miles per gallon. So here we go. We have 5 hours. This is the amount of time that he traveled. We also have 35 miles per hour. Per hour. Here, we know that this is in the right position because it's going to cancel out the hour for us. And that's what we want. We want to cancel out the hours and we want to end up with miles. Now you may be asking why. Well, we want to do that because our next rate is miles per gallon. So we can't use hours to work with that. We need miles. So we want to get rid of the hours. We want to convert this to miles so we can apply the second rate. That is miles per gallon. Okay, so here we go. 5 times 3, 5. Let's do it over here in this corner. 5 times 5 is 25. Carry the 2. 5 times 3 is 15. Plus 2 is 17. So we're left with 175 miles. Now that we have this, we want to answer the question. The question is asking for the number of gallons. So this is where it gets a little tricky. If we have miles on top and we want to cancel out the miles, we have to put the miles on the bottom in this question. And the miles are 25 miles. And on the top, we're going to have gallons because that's what the rate given to us is. So 1 gallon for every 25 miles. We cancel this out here because we want to get rid of the miles because the question is asking us for gallons. So that's what we're looking for. 175 times 1, but this is going to be over 25. So 175 over 25, which essentially means 175 divided by 25. Okay, so 25 goes into 175 7 times. So that means that he used 7 gallons of gasoline to travel for 5 hours. Okay, so let's make sure we understand everything that we discovered in this question. 5 hours, if he's driving at this speed, he drives for 175 miles. We wanted gallons, we want to know how much gasoline he used, so we go ahead and use the rates, the miles per gallon. We put the miles on the bottom so we can cancel out the miles. We're left with the gallons on top. What we did was realize that we have to do 175 over 25, which basically means we divide, and then we get 7 gallons, okay? I hope that helps. Make sure that you go over steps. If there's anything you didn't understand, go over it again until you do. If you got it, then awesome. Let's move on to the next question. A shipment of 5,500 pounds of jelly beans needs to be sorted into 10-ounce bags. How many bags will be needed? Go ahead and give the question a try. right, welcome back. How'd it go? I hope you got it. If not, don't worry, we're going to go over the question together. So let's take a look at the givens first. 5,500 pounds of jelly beans and 10-ounce bags. So our rate, believe it or not, even though this one's a little harder to find, a little harder to catch, it's one bag for every 10 ounces or 10 ounces for every one bag. Okay, that's how we make our rate here. So let's take our total. Let's set it up on here. So we have 5,500 pounds. And we're going to multiply that by our rate, which is 10 ounces for every one bag. Now, we want bags to be on top because that's the unit we want left over. So we're going to put one bag up here, 10 ounces down here. Now, we have a problem here. Pounds and ounces cannot cancel each other out. So we actually have to convert this into ounces, okay? So how do we convert pounds to ounces? Well, we multiply. We know that there are 16 ounces in 1 pound. So we multiply 5,500 times 16. So 6 times 0 is 0, 6 times 0 is 0, 6 times 5 is 30. We carry a 3. 6 times 5 is 30, plus 3, 33. We add a 0 here, and then we can go ahead and multiply again. 1 times 0, 1 times 0, 1 times 5, 1 times 5. We're going to add these up. 0, 0, 0, 8, 8. We end up with 88,000. That is how many ounces we have. So 88,000 ounces times one bag for every 10 ounces, or 10 ounces in every bag. Okay, that's what that means. So by doing this, we cancel out ounces. We have 88,000 on the top, 10 on the bottom, which means we're going to have to divide these. Well, when we have things like this that have a 0, we can just cancel out the zeros that they have in common, and we're left with 8800, 8,800 bags. Okay, we just solved our question. I hope that helps. If you got it, awesome. Move on to the next one. If not, don't worry. Go over the steps again. Look at what you did and compare. And if there's anything that you missed, just keep practicing. If not, let's move on to the next one. All right, next question. A ribbon is 6 feet and 3 inches long. If the ribbon were cut into 5-inch pieces, how many pieces would there be? Give it a try. Welcome back. I hope you got it. If not, don't worry. I'm going to go over it with you. This is our last question together for our rates video, so let's make it count. All right, so this was a little complicated because we have units that we have to change, and they're together. How do we do that? Don't worry. We're going to do it. So our first thing is 6 feet, 3 inches. And we multiply that by the rate of 1 piece for every 5 inches. We know that this is the rate because the question tells us that it's 5 inches for every piece, so we use it as our rate, okay? Now, this is not going to work. We cannot cancel this out. So what we have to do is we have to convert this part of it into inches as well. So we can put them together and then cancel stuff out. So how do we turn 6 feet into inches? We multiply. We know that there are 12 inches in 1 foot. So we do 6 times 12, which we know is 72 inches. We add that to this, which gives us 75 inches. Okay? So let's rewrite this and it'll make more sense. 75 inches times 1 piece for every 5 inches. Well, we can finally cancel out inches, and we're left with 75 over 5, which means we have to divide these. So 5 goes into 75. 5 goes into 7 one time. We're left with 2. We bring down 5. 5 goes into 25 5 times. 5 times 5 is 25. 25 minus 25 is 0. So we can make 15 pieces. Okay, we got it? Awesome. I hope you found those problems helpful. If you didn't understand any one of the steps, make sure to watch the video again or contact us for any additional help. Remember to practice and to use all of the resources available to you. Make sure you're practicing because practice will get you the score you want. Thank you for watching and good luck. You're welcome. So I'm going to go over, let's see, this one is most common rates quiz. Okay, so I'm going to go over the quiz. I'm going to go over each question and give you an explanation for each one. If you have questions, feel free to leave a comment below. So let's look at number 1. It says Kenneth drove for 4 hours at 48 miles per hour. How many miles did Kenneth drive? So the way I like to show rates is to use the same two fractions equal to each other that we use for percents. And the reason I like to show this is because you already know how to work with two fractions equal to each other. It's easy to cross multiply and you're done. Okay, so I'm going to keep showing it to you like that. So the way we set that up is that we take the rate and we split it up. So we have our two fractions. 48 miles for every 1 hour is the way that I like to split up rates. But I'm going to set that up over here. 48 miles for every 1 hour. That's my rate, okay? And it says that he drove for 4 hours. How many miles did Kenneth drive? So now that I have my rate set up, I know that the 4 hours is going to go down here because the hours is down there. If you remember, when we set up our two fractions, we want to make sure that the hours and hours are the same, and the miles, x miles, and miles are the same on the top. Okay? So now we have our two fractions equal to each other. What do? We cross multiply. So 1 times x is just x. And now 48 times 4, we're going to multiply over here because that's a little bigger and we can't do it in our head. That's okay. 4 times 8 is 32. So I put a 2, carry the 3. 4 times 4 is 16, plus 3 is 19. So 48 times 4 is 192. My answer then is 192 miles. So this one was pretty straightforward, kind of easy to start us off, right? Let's look at the next one. Now remember, we're splitting up the rate. When we find the rate, we're going to split it up into our fractions. So let's read the question first. Talia types 84 words per minute. That's her rate. Let me underline that. If she typed a document with 336 words, how much time did it take her to type up the document? Okay, so let's split up our rate. Let me set it up here. She does 84 words for every 1 minute, okay? And we want to know
if she has 336 words, remember I'm setting it up on the top because I want the units to be the same, words and words, okay? I don't know how long it will take her to do 336 words, so I'm going to call it X minutes. That's what I'm solving for. And guess what? It asks us how much time, so that's perfect. So now I'm going to cross multiply. 84 times X is 84X, and 1 times 336 is 336. So now I'm going to isolate the X by dividing by 4, 84. Why do I divide by 84? Because that 84 is multiplied to the X. So to get rid of it, I do the opposite. I divide by 84. Okay, now that is a complicated number to work with, so I'm actually going to set up my division problem over here. So 84 cannot go into 33. It's too big. So we have to do 84 directly into 336. So what I like to do is I like to think, okay, let me round this to 80. 80 times 2 is 160. So it's definitely not that. It has to be higher. 80 times 3 is 240. It needs to be higher than that. So let's try 80 times 4. Well, that's 320. That's pretty close. So why did I do this? I estimated because I'm working with big numbers. And if I say here and I multiply again and again and again, it's going to take too long. So what I like to do is I like to round to something close by and kind of get an idea. Okay, you know what? Let me multiply by this or by this. And that way I do less work. And I save some time, which is important, right? So let's do 84 times 4. 4 times 4 is 16, carry the 1. 4 times 8 is 32 plus 1, 33. So what's 336 divided by 84? It's 4. 336, I subtracted a 0. So X is equal to 4. Now, what is the unit here? Is it 4 minutes or for 4 hours? Because I have two options. Well, it's minutes. Because remember, 84 words per minute, X minutes. The units are the same. So I'm going to do 4 minutes here, and I know that my answer is the first one. Okay? All right. You know what? Let's move on to number 3. It says, a janitor was cleaning a school with 240 classrooms. If the janitor spends an average of 35 minutes cleaning each classroom, how long will it take to clean 12 classrooms on the first floor of the school? This one has a lot of numbers. So let's make sure we know which numbers are the ones we actually need. And you know what? Maybe there's extra numbers, and I can almost guarantee that. So first of all, what is the question asking us for? It's asking for how long will it take to clean 12 classrooms, okay? And what is our rate? It says 35 minutes per classroom. So let's set up our fraction. We already have a rate, so let's set up our fraction. 35 minutes for one class. So if it's asking how long, let's call it X minutes. How many classrooms? To clean 12 classrooms. 12 class. What is this 244? This is telling us how many are in the entire school. But the question is not asking us for the time for the entire school. It's asking for just the first 12 on the first floor. So this is extra information. Okay? So let's cross multiply. X times 1 is X. And 12 times 35, let's do it over here. 35 times 12, 2 times 5 is 10. Carry the 1. 2 times 3 is 6, plus 1 is 7. My placeholder 0. 1 times 5 is 5. 1 times 3 is 3. 0. 7 plus 5 is 12. 1 plus 3 is 4. So 420 minutes. Okay? 420 minutes are not an option. This is minutes and this is minutes, but none of them are 420. So this is either hours. 7 hours or 70 hours, which means we have to convert this to hours. Well, how many minutes are there in 1 hour? There are 60 minutes in 1 hour. Look at that. This is another rate. So we're trying to do 420 minutes. Let me erase this. I can have some space. Okay, there we go. So we have to do 420 minutes is how many hours? 60x equals 420. Divide by 60. I can eliminate a 0 on the top and the bottom. 42 divided by 6 is 7 hours. So my answer is 7 hours. Okay, this one was a little more complicated. So if there's something that you maybe feel you want to see it again, feel free to just rewind this or go back a couple minutes and watch the whole process. Pause, think through it, okay? If you still have questions, just leave a comment below. But for now, I'm going to go ahead and erase this because this one took up a lot of space and I want to make space for the next one. So the answer was 7 hours. I'll leave that there. Number 4. It says, Jacob drove for 3 hours at 65 miles per hour. If his car used 1 gallon for every 15 miles, how many gallons of gasoline did Jacob use? So here we have two rates, okay? Our first rate is 65, wrong one. Our first rate is 65 miles per hour. And our second rate is 1 gallon for every 15 miles. So that means we can go from miles to gallons, okay? So first things first, if we want to know how many gallons he used on a trip, and the gallons that he uses depend on how many miles he travels, then let's find out the number of miles he travels, okay? So let's use our first rate here, 65 miles for every 1 hour. How long did he drive? 3 hours. And that's X miles. We have an idea how much that's going to be. So let's cross multiply. 1 times X is X. And 65 times 3. 3 times 5 is 15, carry the 1. 3 times 6 is 18, plus 1 is 19. So 65 times 3 is 195 miles. That's how much he traveled, okay? Now we want to know how many gallons that is. Well, it tells us here in our second rate that it's 1 gallon for every 15 miles. So let's set it up in our equation. 1 gallon for 15 miles. And we want to know how many gallons for 195 miles. Okay, we're good. So now let's cross multiply. 15 times X is 15X. 1 times 195 is 195. That 15 is multiplied to the X, so I'm going to divide it. Let me make some space over here. I'm going to set up my division problem. So 15 goes into 19 one time. 15 times 1 is 15, and 19 minus 15 is 4. I'm going to bring down the 5. 15 goes into 45 3 times. 15 times 3 is 45, and 45 minus 45 is 0. There are no more numbers to bring down, and that's it. So X equals 13. and this is gallons, right? Because X gallons over here. So this is our answer, 13 gallons. All right, I hope you got it. When you're ready, let's move on to the next one. Okay, number 5. There are 246 students and 2 chaperones going on a field trip. If a chartered bus can hold 45 individuals, how many buses will be needed to transport everyone going on the field trip? How many buses? So the question is asking us for the number of buses to transport everyone. Well, how many people are there in total? There's 246 students and 2 chaperones. That's 248 people. Okay, and our rate here, believe it or not, is 1 bus for every 45 people. So I'm going to set up my equation. 1 bus for 45 people. Okay, and I want to know the number of buses for 248 people. So we cross multiply. 45x equals 248. Now I'm going to divide. Oh my goodness, what am I doing? I'm sorry. There we go. And I'm going to set up my division problem over here. Now, this one, I can do 45 goes into 24, so I have to do it completely into 248. But remember what I told you. We always round these big numbers to something, and it'll be easier to estimate what number it's going to be. So I'm going to estimate this 45 to 50. So 50 times 4 is 200, which means that this is probably going to be 50 times 5, which is 250. Okay, so let's do 45 times 5. That's 25, carry the 2, 225. So it's about 5 buses. But when we have 5 buses, we're still going to have 23 people left over, which means we're going to need 1 more bus, which means we're going to need 6 buses. So what's confusing about that question is people get 5 and they say, okay, we only need 5 buses. No, that's only part of the question. You still have people left over. They can't walk. So you're going to need 6 buses. Okay? I hope that made sense. Now, some of you might be thinking, well, this is a long way to do something that all I have to do is just divide 248 by 45. Yes, I understand that. But the reason I show you the long way is because not all questions are going to be so straightforward like this one. So I just keep doing all of the same rate questions the same way to make sure that the answer is correct every single time while I'm teaching you. If you want to use a shortcut, I hope it works for you. I'm sure it will. Just make sure that you are familiar with this method when the questions get more complicated, okay? So with that said, let's keep going to number 6. Let's make some space, and let's keep going to number 6. It says, Stephanie typed up a document at the speed of 88 words per minute. Oop, that looks like a rate, 88 words per minute. It took her 22 minutes to type up the document, and each page had 150 words. Another rate. How many pages long was the document? All right, so first things first. What is the question asking us for? The number of pages, okay? It tells us that there are a certain number of words per page. So, you know what? Let's figure out how many words there are, and then we'll figure out how many pages there are, okay? So, it gives us 88 words per minute, and it tells us it took her 22 minutes. So, I'm going to set up my first equation. So, it's 88 words for every 1 minute, right? And I want to know the number of words for 22 minutes. If she was typing 88 words per minute for 22 minutes, how many words did she type? So, we have 1 times x, we're going to cross multiply now, is x. 88 times 22, we're going to do it over here because it's not that obvious. So, 2 times 8 is 16, carry the 1. 2 times 8 is 16, plus 1 is 176. Placeholder, 2 times 8 is 16, put the 6, carry the 1. 2 times 8 is 16 again, plus 1 is 17. So let's add these up. 6, 13, carry the 1, 9, and 1. 1,936 words. That's what she types in 22 minutes, okay? Now, we want to know the number of pages. If each page, 1 page, is equal to 150 words, what is the number of pages for 1,936 words? So I'm going to cross multiply again. I'm going to remove this so I have some space to work here. 150x is equal to 1,936. I'm going to divide by 150. I'm going to put that over here. Okay, so how many times does 150 go into 193? 1 time. We're going to multiply and now subtract. 3, 4. Okay, now we're going to bring down that 6. How many times does 150 go into 436? 2 times. 150 times 2 is 300. That leaves me with 136 left over. This is 136 words. That means we fill 12 pages, plus on the 13th page, we have 136 words left over. So how many pages long is the document? Is it 12 or is it 13? It's 13 pages long, because 12 is not enough to hold all the words. This is kind of like the best question, okay? All right, I hope this made sense. If you need to see it again, feel welcome to do it. Just kind of click back and watch this one problem again. If you want to click back and try it, and then watch the explanation to see if you got it right this time, that's a good idea also. Go ahead and continue with number 7. So number 7 says water is being pumped into a container at a rate of 3 gallons per minute. So we have a rate here, 3 gallons per minute. If each container has a capacity of 15 gallons, how long will it take for water to be pumped into 240 containers? Let me read the question again. How long will it take for water to be pumped into 240 containers? So we're looking for time, okay? And this has a second rate. It has 3 gallons per minute, and each container 15 gallons, okay? So let's start with this. Let's figure out if we get to how long will it take, right? We're looking for time. This rate has time, 3 gallons per minute. What we need to figure out is how many gallons there are in total. It doesn't tell us the total amount of gallons, but it does tell us the containers, and it does tell us how many gallons per container. So we can use this information to find the total number of gallons and then figure out the number of minutes. Okay? So let's start with 240 containers. Is to X number of gallons. And one container is 15 gallons. Let's cross multiply. 1 times X is X. 240 times 15. Let's do that up here. 5 times 0, 0. 5 times 4 is 20, carry the 2. 5 times 2 is 10, plus 2 is 12. And I put in a 0 as a space holder. 1 times 0 is 0, 1 times 4 is 4, 1 times 2 is 2. 0, 0, 6, 3. So 3,600 gallons. That's what we have in total. Now, we want to know the time. So now we're going to use our 3 gallons per minute thing, okay? So we have 3 gallons for every 1 minute. And we need to fill 3,600 gallons in X number of minutes. Why do I put minutes? Because this is minutes, so this has to be minutes. Remember, their units have to be the same, okay? So let's cross multiply. 3x is equal to 3,600, which means now I have to divide by 3. So let's do it up here. 3 into 3,600. 3 goes into 3 one time. Sorry, brings down to 6. 3 goes into 6 2 times. Bring down a 0. 3 goes into 0 0 times. Bring down another 0. 3 goes into 0 0 times. So X equals 1,200 minutes. But 1,200 minutes is not an option. We have it in 120 minutes. That's no good. The other ones are in hours. So now I have to turn these minutes into hours. So 1,200 minutes is an unknown amount of hours, but I know that 60 minutes equals 1 hour. So let me make some space over here. Now what I'm going to do is I'm going to cross multiply. 60 times X is 60X. 1,200 times 1 is 1,200. So now I'm going to divide by 60. I can actually eliminate a 0 here. So now I'm left with 120 divided by 6. 6 goes into 12 2 times. 6 times 2 is 12. Bring down the 0. 6 goes into 0 0 times. And that's it. X equals 20 hours. Okay? That one was a little more challenging because that one required us to do this 3 times. So if you got confused, go back and take a look at it again. That's not a problem. If you're ready, I'm going to go ahead and move on to the next one. Erase and make some space. Oh, sorry. There we go. Okay, number 8. A flight leaves Brownsville heading north at a speed of 200 miles per hour. This is a rate. Another flight leaves at the same time from Brownsville, heading south at a speed of 300 miles per hour. If both flights leave at 1 p.m., at what time will the 2 planes be exactly 2,000 miles per hour? Okay, so this one's a little bit different. For this one, I'm actually going to draw something for you. So let's say this is Brownsville. And there's a flight that leaves north, 200 miles per hour. So every hour, this one travels 200 miles. Another one leaves in the opposite direction, south, at 300 miles per hour. Okay, so if it's 1 hour, this one goes 200 this way, this one goes 300 this way. 1 hour is equal to 500 miles. Okay, if both flights leave at 1 p.m., at what time will the 2 planes be exactly 2,000 miles apart? Well, it takes them 500 miles, takes 1 hour. How long will it take to go 2,000 miles? 500x equals 2,000. I'm going to divide by 500. I eliminate some zeros because they have them in common. And now 20 divided by 5 is just 4. X is 4 hours. So I'm going to go over that again one more time. What I did is I figured out these flights, how far apart are they in 1 hour? 200 in this direction, 300 in this direction. So a total of 500 miles every 1 hour. So I use that as my rate over here. And I compare it to the 2,000 miles. Okay? That gives me 4 hours. I cross multiply. 500 times x is 500x. 1 times 2,000 is 2,000. And when I divide by 500 to isolate the x, I end up with 4. Now, is it asking me how many hours it takes? No, it's asking me at what time. Well, the start time for both of them was 1 p.m. So 1 p.m. plus 4 hours is 5 p.m. Okay? If that one was weird, feel free to go back and take a look at it. You might even want to try it again on your own and see if you can figure it out. When you're ready, I'm going to move on to number 9. Okay. Number 9 says, a shipment of 3,500 pounds of chocolate candies need to be sorted into 8-ounce bags. How many bags will be needed? So this one has a rate, but it's not as obvious. The rate here is 8-ounce bag. 1 bag is equal to 8 ounces. We want to know how many bags, so X bags, are needed for 3,500 pounds. But the problem here is that I cannot put 3,500 pounds here. Why? Because this is ounces and this is pounds. That doesn't work. So I have to convert the pounds to ounces. How do I do that? Well, there are 16 ounces in 1 pound. I'm going to do that as a rate. So 3,500 pounds is to X ounces, as 1 pound is to 16 ounces. So X times 1 is X. 3,500 times 16 is going to be a big number. So let's multiply it up here. 6 times 0 is 0. 6 times 0 is 0. 6 times 5 is 30. 6 times 3, 18, plus 3, 21. So this is 21,000. sorry. No, it's not. I'm not done. I'm having a moment. Okay, so now we put our placeholder 0 and we multiply by the 1. 0, 0, 5, and 3. 0, 0, 0. We're adding these up now. 6, not 8, 5. Okay, one more time. 0, 0, 0, 6, 5. So now this is 5,600. Sorry, 56,000. Okay, I hope you got that. I know that one was a little tough. So 3,500 times 16 is equal to 56,000. Now that we know the number of ounces, we can put that over here. So 56,000 ounces. Now let's cross multiply. I'm going to make a little space for myself here. 8 times x is 8x. 1 times 56,000 is 56,000. I'm going to divide by 8. Give me 1 second. I'm going to move this. Now I'm going to set up my division problem. 8 goes into 56 7 times. 8 times 7 is 56. 56 minus 56 is 0. But I have all these zeros, so I have to bring down each one. 8 goes into 0, 0 times. 8 goes into 0, 0 times. 8 goes into 0, 0 times. I have no more zeros to bring down, so I am done. My answer is 7,000 bags. Okay? Alright, I hope that one makes sense. If you have any questions, leave a comment below. I'd be happy to help you with it. Let me go ahead and move on to number 10. It says, a ribbon is 4 feet and 5 inches long. If the ribbon were cut into 3-inch pieces, how many pieces would there be? So, we want to know the number of pieces. X pieces. 1 piece is 3 inches. Now, I can't just put 4 feet, 5 inches here, because this is not in feet and inches, it's just in inches. So I have to convert this to inches, the whole thing. So, 4 feet, 5 inches. The 4 feet, how do I turn that into inches? I know there's 12 inches in 1 foot. So 12 inches, 1 foot, equals x inches over 4 feet. 1 times x is x. 12 times 4 is 48 inches. Oh, I still have this 5. Don't forget the 5. So I have to do 48 plus 5, which is 53 inches. So now that I have that, I can put that here, and I can cross multiply. 3x equals 53. 3 goes into 5 one time. 3 times 1 is 3. 5 minus 3 is 2. I bring down the 3. 3 goes into 23 7 times. 3 times 7 is 21. There's 2 inches left over. So there's 17 pieces. Okay, I hope you got that. Let's move on to number 11. Number 11 says, an employee was cleaning an office building with 20 offices. If the employee spends an average of 25 minutes cleaning each office, how long would it take to clean 7 offices on the first floor of the building? Now, we did one similar to this earlier. And when we did, it gave us extra information. Remember that the question was actually asking us for how long it would take to do like the first floor. And here it's doing the same thing. It's saying how long will it take to clean the 7 offices. Not the 20, but the 7. Okay, so that's important. Just paying attention and knowing exactly what information is necessary. So now that we have our necessary information figured out, let's focus on finding out the time. So we know that we're working with 7 offices. We want to know how much time that is. Sorry. X. Okay. And we know that 1 office takes 25 minutes. Because this one is in minutes, this will also be in minutes. Okay. All right, let's cross multiply. X times 1 is X. 25 times 7, let's multiply it over here. 7 times 5 is 35, carry the 3. 2 times 7 is 14, plus 3 is 17. So 175 minutes. And that's already given to us. Perfect. That was a straightforward one. Just make sure that you identify the information you actually need. I'm going to go ahead and move on to number 12. Excuse me, it says, Kalen drove for 7 hours at 64 miles per hour. If his car used 1 gallon for every 32 miles, how many gallons of gasoline did Kalen use? So, this is similar to another question we did earlier, so let's just kind of do it again. We want to know the number of gallons, right? And here it gives us two rates. It gives us 64 miles per hour and 1 gallon for every 32 miles. So the first step we're going to take is we're going to find the number of miles in total. Because if we want to know how many gallons he used, we have to know how many miles he drove, right? Because the number of gallons that he used depends on how many miles he drove. So, how many miles did he drive? It doesn't tell us. It gives us a rate, and then it tells us how long he did that for. So let's use that rate. 7 hours is X miles is equal to 1 hour, 64 miles. Okay, so our rate is 64 miles per hour. I compare it to the 7 hours that he drove, and I want to find out the number of miles he drove. So I'm going to cross multiply. X times 1 is X, and 64 times 7, I'm going to do it up here. 7 times 4 is 28, carry the 2. 7 times 6 is 42, plus 2 is 44. So 448 miles. Perfect. Now, how many gallons did he use? Well, we know that he does 32 miles for every 1 gallon. And we know that he's traveling 448 miles. How many gallons is that? So let's cross multiply. 32 times x is 32x. 1 times 448 is just 448. And now I'm going to divide by 32 on each side. Okay? So 32 into 448. So 32 goes into 44 1 time. 4 minus 2 is 2. 4 minus 3 is 1. and I'm going to bring down that 8. Okay, so 32 goes into 128. I know 30 times 4 is 120. Remember I told you sometimes it's good to just kind of round it and estimate. So I'm going to try 32 times 4 because I think that's pretty close. 4 times 2 is 8. 4 times 3 is 12. And there we go. 128. And we're done. So how many gallons did he use? 14 gallons. Okay, I hope you're getting better at this. I hope you're understanding. I'm going to make some space, and I'm going to move on to number 13. We're almost done with this quiz. Okay, it says, Sabrina typed up a document at the speed of 95 words per minute. If it took her 8 minutes to type up the document and each page has 180 words, how many pages long was the document? So once again, this is very similar to the question that we did earlier. If you want to hit pause before I do the explanation and give it a try, since you've already seen the explanation, you're more than welcome to do that. But when you're ready to look at it together, I'll go ahead and watch this because I'm going to get started with it, okay? So we're looking for how many pages there were, okay? And we know the rate is 95 words per minute. It took her 8 minutes to type, and that each page has 180 words. So we have 2 rates here at a time. So let's see. If we want to know the number of pages, then we have to know how many words there are, because the number of pages depends on the number of words. So let's start with words. We don't know how many words there are, but we know that she types 95 words for every 1 minute. And we know that she did that for not 7, 8 minutes. How many words are there? 1 times x is x. 95 times 8. Let's multiply real quick. 8 times 5 is 40. Carry the 4. 8 times 9 is 72. Plus 4 is 76. So Sabrina typed up 760 words. So now that we know how many words there are, let's see how many pages we need to hold all of those words. Okay? So we have 180 words for every 1 page. And we have a total of 760 words, and we don't know how many pages it'll take. So far, so good? 180 times x is 180x. 1 times 760 is 760. I'm going to divide by 180 on each side, and look at that, I get to eliminate some zeros. I love eliminating zeros because that means I get to work with smaller numbers. So now 18 goes into 76. All right, so remember, we have to estimate this because I don't know this off the top of my head. So I'm going to round it to 20, and I know that 20 times 4 is 80. So let me try 18 times 4. 4 times 8 is 32. 4 times 1 is 4, plus 3 is 7. So 18 times 4 is 72. That's actually really close. So I'm going to put that over here. 4, 72, there's 4 words left. That means that 4 pages isn't enough. We need an additional page, 5 pages. Okay? I hope you got it. Remember, you can always go back and rewatch the explanation. When you're ready, I'm moving on. So it says, number 14, water is being pumped into a container at a rate of 2.5 gallons per minute. If each container has a capacity of 15 gallons, how long will it take for water to be pumped into 130 containers? So we want to know the amount of time. Let's see, how long will it take for the water to be pumped for 130 containers? It gives us the capacity, 15 gallons per container. That's a rate. And it also gives us the time. So the first thing we need to know is how many gallons there are, because the time depends on the number of gallons. It doesn't tell us the total number of gallons, it tells us the total number of containers. But we can use that information to figure out the number of gallons. So 130 containers to x gallons is equal to 1 container is equal to 15 gallons. 1 times x is x. 130 times 15, we're going to figure out right now. 5 times 0 is 0. 5 times 3 is 15, so I put a 5, carry a 1. 5 times 1 is 5, plus 1 is 6. Keep going, right? Put a 0 as a placeholder. 1 times 0 is 0. 1 times 3 is 3. 1 times 1 is 1. So 0, 5, 9, 1. There is a total of 1,950 gallons. Now, let's figure out how much time it's going to take to do this. So 2.5 gallons for every 1 minute. And I want to fill 1950 gallons, that's a lot of gallons, in x number of minutes, right? So now x times 2.5 is 2.5, you know what, I don't like it here, let's do it over here. 2.5x, and 1 times 1950 is 1950. So now I'm going to divide 2.5 by 2.5 to isolate the x, and I'm going to set that up here. So 2.5 into 1950. So if you remember our lesson on division, we can't have a decimal here. So we actually have to move it over, and when we do that, we move over a decimal point here. But this is a whole number, which means the decimal point is at the end, and we actually end up adding a 0. So this will look like this. 25 goes into 19,500, okay? So how many times does 25 go into 19? Can't do it, it's too big. So we have to do how many times does 25 go into 195? Well, I'd like to think of 25 as quarters, and 25 times 4 is $1, right? 4 quarters is $1. So 25 times 4 is 100. 25 times 8 is 200. So I'm going to do 7. 25 times 7, I'm going to show you over here. 7 times 5 is 35, so carry the 3. 7 times 2 is 14, plus 3, 175. So now I subtract it. 0, 9 minus 7 is 2, and I bring down a 0. 25 goes into 200 8 times. 25 times 8 is 200, and now I subtract, and I get 0. But I still have to bring down another 0. So 25 goes into 0, 0 times, and now I'm done. Okay? So 780 minutes. That's what I have. Is that an option? Yes, it is. Perfect. All right. I'm going to make a little bit of space here. And we're going to do the last one. So this one says, a flight leaves New Haven heading north at a speed of 150 miles per hour. Another flight leaves at the same time from New Haven heading south, so in the opposite direction, at a speed of 200 miles per hour. If both flights leave at 4 p.m., at what time will the two planes be exactly 1,400 miles apart? So this is similar to another question we had before. If you feel like you understood how to do that last question and you're ready, then hit pause and just give it another try on your own. When you're ready to see the explanation, I'll go ahead and give it to you now. Okay? So we have our point, New Haven. One flight goes north 150 miles every 1 hour. The other one goes south 200 miles every 1 hour. That means that the total separation between the two planes every 1 hour is 350 miles per hour. Okay? Now, we want to know how long will it take to get 1,400 miles apart. So 1,400 miles is X hours if they're separating by 350 miles every 1 hour. So 350 times X is 350X. 1,400 times 1 is 1,400. I'm going to divide by 350 to isolate the X. I get to eliminate a 0, which you know I love to do. Now 35 goes into 140. 35 goes into 140. Let's try 35 times 2, I know is 70. So let's do 35 times 4. 4 times 5 is 20. 4 times 3 is 12 plus 2, 140. Perfect. This is 4 hours. Okay? Now, it doesn't ask me how long it's going to take. It asks me at what time will they be exactly 1,400 miles apart. So 4 p.m. plus 4 hours is 8 p.m. Be careful with the 8 a.m. This is not it. 8 p.m. Okay? I hope that was helpful. Please comment below if you have any other questions. Good luck.
Hi, welcome to the ratios video. So let's talk about ratios. Ratios can be expressed in different formats. Fraction, a 1-to-1 with the 2 dots in the middle, and in words. In a group of 20 people, 8 are women and 12 are men. The ratio of men to women is 12 to 8, or 12 over 8. The ratio of women to men is 8 to 12, or 8 over 12. Both of these ratios should be simplified, so the ratio of women in the group is 8 to 20, or the proportion of men in the group is 12 to 20. It is important to pay close attention to the words used in the question. Alright, so I just want to make sure you understand this. If there are 20 people in a group, 8 of them are women and 12 of them are men, there's a lot of ratios that we can do here, okay? So I wrote it for you here. 20 people in total. So this is our total. 8 women, 12 men. So let's identify these to make sure you understand it. This is our total. This is a part. This is a part. When we add these together, they equal the total. Got it? So we can say that the ratio of men to women, if we say men to women, is 12 to 8. Or 12 to 8. If we say the ratio of women to men, it's 8 to 12, or 8 over 12. The order that you put it in, or the number that goes in the numerator denominator, depends on the way the question put it in, or the number that goes in the numerator denominator depends on the way the question is worded, or the way the ratio is worded. Got it? Usually when we do this, we'll simplify this so we have smaller numbers. So this can be divided by 4 top and bottom in both of these fractions. Typically, you'll see this written as 3 to 2, and this one would be 2 to 3. That's another thing that they might ask you in one of these ratio questions. You have to make sure it's simplified. It could be written either way, but most of the time it's going to be simplified, okay? Sometimes it'll ask you to compare a part to the whole. So we could have the women out of all the people there would be 8 to 20, or 8 over 20. Remember, we can simplify this. This would be, 2 to 5, or 2 to 5. Same thing goes for the men, 12 to 20, 12 over 20, okay? So now that you understand the different ways that we can write these ratios, the different ways we can express them, and the different ways we would be asked that question, let's go ahead and take a look at what these questions would look like. This will be revealed by the words used in the question. So let's take a look at some examples. In a theater audience, there are 300 people. 80 of those people are children. What is the proportion of children in the audience? What is the proportion of children to adults in the audience? Awesome. How did it go? I hope you got it. If not, don't worry. We're going to go over the question together and you can break it down step by step with me. So let's take a look at the givens. And let's go ahead and after we look at the givens, let's look at the questions. All right. So the question gave us 300 people in total, 80 children. So there's 80 kids out of these 300 people. This is the part. This is the whole. The first part of this question says, what is the proportion of children in the audience? So we are comparing the number of children to the total number of people that there are. So we would say 80 to 300 or 80 over 300. We want to simplify this because this is a very large number, okay? So remember, when we have numbers the same top and bottom, well, not numbers the same, I'm sorry. When we have a 0 in common in the top and bottom, we can automatically eliminate them, so that's easier. So we're left with 8 over 30. We can also simplify this further by dividing by 2 because they're both even numbers. So let's do that. 4 over 15. So to answer the first question, we know that the ratio of children to the people in the audience is 4 out of 15. We can write it as a fraction, or we can write it with the goal lines. Most of the time, you'll be able to tell which one to do by looking at your answer choices. Let's take a look at the second part of this question. It says, what is the proportion of children to adults in the audience? Well, this question is a part-to-part question, and we only have one of the parts. Can we solve for the second part of this? Yes, we can. We can subtract these two numbers. So we can subtract a part from the whole. Because remember what I told you in the last example, the two parts will add up to the whole, or however many parts there are, they will add up to equal the whole, okay? So let's do 300 let's do 300 minus 80, okay? 300 minus 80 is 220. That's the number of adults that there are. And remember, the question says, what is the ratio of children to adults in the audience, okay? So we're comparing the two parts. It gives us children first, so that means we're gonna put the 80 first, okay? So 80 to 220. We're not going to use a 300 here because it's not asking us for that. It's asking us for the two parts. We can also write it as a fraction. And again, like we did over here, we can eliminate this common 0 on the top and the bottom. And they're both even numbers, so we can divide by 2 on the top and the bottom to simplify this. 8 divided by 2 is 4. 22 divided by 2 is 11. So our ratio for children to adults, just like the question asked us for, is 4 to 11, either as a fraction or written in this format as a ratio. All right, let's look at the final part of this question. It says, what is the proportion of adults to the audience? So now we're comparing, once again, a part to a whole. We're going to compare this part right here, and this is our whole. So let's write it in the same way we've done with these other ones. 220 to 300, or we can write it as a fraction. We can eliminate the common zeros, and we can divide by 2, top and bottom, and we get 11 to 15. And we went ahead and put it in both formats there. 11 over 15 or 11 to 15 with the colons. Let's take a look at one of the word problems that you could come across on the math problem. Let's go. A man dies and his life insurance payout is $75,000. He listed his wife and son and beneficiaries in a 3-to-2 ratio of the wife's share to the son's share. How much will his son receive from the life insurance payout? Okay, great. So now that you've given that a try, let's do the problem together. So we know that the total is 75,000. That's what the payout is. The problem also tells us that there's a 3-to-2 ratio for the wife and the son to share. So 3 to 2. This is the wife, this is the son. It's important to understand that in this ratio problem, we have a part compared to a part. So the wife gets a part of this, 3, that's the part. The son gets a part, 2, okay? So if we want to tell the total, we actually have to add these up. So we're going to do 3 plus 2, which is easy, right? 3 plus 2 is 5. So we know that the wife gets 3 out of 5 and 2 out of 5. Because remember, this ratio is comparing part to part. So let's make sure we understand what's happening here. This means that for every $5 out of the $75,000, the wife is getting 3 and the son is getting 2. Does that make sense? So now let's make sure we understand what the question is asking us for. The question is asking how much will the son receive? So we're going to focus on this right here. The ratio for the son, or our fraction, the ratio for the son. To be able to find out how much this is from here, what we do is we multiply them. So we're going to do 75,000 times 2/5. We can put a whole number over 1. What we're going to do first, I always like to divide first because I don't like working with really large numbers, and this is a big number. So let's do 5 divided by 75,000. So 5 goes into 7 one time. 5 times 1 is 5. 7 minus 5 is 2. We can bring down the 5. 5 goes into 25 5 times. 25 minus 25 is 0. We can keep bringing down these zeros. And we're going to end up with 15,000. Okay? So let's make sure we understand what's happening here. We have 75,000. That's our total. We're multiplying this by 2/5 so we know how much the son is getting. Essentially, when we're multiplying, this means 75,000 times 2 divided by 5. Okay? So because I told you I don't like working with big numbers, I'm dividing first so I can make it smaller. All right? And I end up with 15,000. So the next thing I have to do since I divided first, is I need to multiply. So if I do 15,000 times 2, 2 times 15 is 30. We have 3 zeros, 30,000. So we know that the son is getting $30,000 out of the $75,000 payout that his dad left him. All right, I hope you got it. If not, go back, make sure you check your steps and you realize maybe where you made some mistakes. And if you're ready, let's move on to the next question. All right, let's look at question number 2. There were 120 students on a field trip to Orlando. The ratio of boys to girls was 2 to 1. How many boys were there on the trip? You got it. If not, don't stress out. We're going to go over how to do this together. I'll guide you through it step by step. So let's look at the givens from the problem. Remember, we always start out with the givens, and then we have to understand the question, and then we can solve it, okay? So we know that there's 120 students, and we know that the ratio is 2 to 1 for boys to girls. So let's look at what that looks like. So 120 is our total, and we have a ratio of 2 to 1. 2 boys for every 1 girl. Okay, now let's make sure we understand what that ratio means. That means that for every 2 boys, there's 1 girl. This is a part. This is comparing part to part. Does that make sense? Okay, so to get the whole, we have to add them up. So 2 plus 1 is 3. That means that if we were to express this as a part to a whole, for every 3 children, there are 2 boys. For every 3 children, there's 1 girl. I hope that makes a little more sense. So let's see. What is the question asking us for? It says how many boys were on the trip. We're looking for the number of boys. So we're going to focus on this ratio here. Got it? All right, let's multiply. Remember what we did with the last one? We multiplied our whole times our part to whole ratio. Okay? So 120 times 2/3. Our whole number can be over 1. Now remember what I told you. I always try to divide first because I like working with smaller numbers. So I'm going to do 120 divided by 3. 3 goes into 12 4 times. 12 minus 12 is 0. You bring down that 0, and you got 40. Okay? Now that we divided, the next thing that we need to do is we need to multiply. So we're going to do 2 times 40. Well, that's easy, right? 40 times 2 is 80. So we know that there are 80 boys out of this total of students. How'd it go? I hope that made sense to you. Please make sure to go back and go step by step if there was anything from that question that you did not understand. All right, good luck.
So we're going to get started with number 1. I'm going to go over these questions for the quiz. I'm going to try to explain this as kind of like easy as possible. If you have any questions, please leave a comment below and I'd love to help you, okay? So number 1 says, in a theater audience, there are 300 people. 80 of those people are children. What is the proportion of children in the audience to the total people in the audience? So here it says proportion, but we're working with ratios. And ratios mean that there's like a scenario and we can compare the things in that scenario. So one way of explaining this is saying inside a jar, there are a bunch of coins. And there are, of these coins, there's 2 types. Some coins are dimes, and some coins are quarters. Okay, so let's say there are 30 dimes and 50 quarters. There are a total of 80 coins in the entire jar. Okay, how do I know there are 80 coins? Because 30 plus 50 is 80, and that's all of, there's no more coins aside from dimes and quarters. Okay, so a ratio is if we were to compare 30 dimes to 50 quarters. And we do it, and we simplify it. So divided by 10, the ratio is 3 dimes for every 5 quarters. Okay? Same thing goes with 50 quarters and 80 total. If I were to simplify this, I would divide by 10, and I get 5 dimes, 8 quarters. In this question here, in number 1, so now that I've explained this to you, let me make some space. So in number 1, it says there's 300 people, so that's my total. And out of those people, there are 2 kinds. There's 80 children, and then there's adults. Okay? We don't know the number of adults, but if we wanted to know, we would just subtract 300 minus 80, and that gives us 0 minus 0 is 0, 10 minus 8 is 2, 220 adults. Okay? But the question is asking us for the proportion of children, okay, children to total people. So we don't really care about adults right now. We're just focusing on 80 to 300. So let's simplify this because all of these have to be simplified. So let's do divided by 10, that's 8 and 30. But we can simplify this even further by dividing it by 2, which gives us 4 and 15. This is our simplest form, and guess what? It's also our answer. So that's how we write a proportion or a ratio, okay? It's the colon between, just means that you're comparing these 2 scenarios. So now that we kind of know what a ratio is and how to write one, how do we do questions that are ratios? So let's look at the second question, and hopefully we'll make sense of it. It says, a man dies and his life insurance payout is $75,000. He listed his wife and son as his beneficiaries in a 3-to-2 ratio of the wife's share to the son's share. In ratios, we pay attention to the words. 3 to 2, wife to son. So the wife gets 3, and the son gets 2. How much will his son receive from the life insurance payout? So here, let's finish our ratio by adding them. And the total is 5. So this is our ratio. And this ratio gives us information to set up our equation, which is just 2 fractions equal to each other, okay? Here, we get to compare a scenario, wife to son to total, wife to total, son to wife, whatever we want, okay? How do we decide what goes where? We decide based on the rest of the information in the question, okay? What else does the question give us? It gives us the total, so it looks like we're gonna use total, okay? And what does it ask us for? Son. So guess what? We're gonna use son. We're not gonna use a wife because it just doesn't, we don't need that information. The first fraction is going to be our ratio fraction. So 2 son, 5 total is equal to x son, because we don't know how much the son is getting, and the total is 75,000 here. Notice that our son and our son are lined up in the top, our total and our total are both on the bottom. So we have to keep everything in place like that. So now let's cross multiply. 5 times x is 5x. And 75,000 times 2, let's figure that out over here. 2 times 0, 0, 2 times 0, 0, 2 times 0, 0. 2 times 5 is 10, carry the 1. 2 times 7 is 14, plus 1 is 15. So 150,000. We're going to divide by 5. We divide by 5 so we can isolate the x. That 5 is multiplied to the x, so we have to do the opposite, which is divide. And now we're going to do 150,000 divided by 5. 5 goes into 15 3 times. 5 times 3 is 15. Now to bring down all these zeros. 0, 0, 0, 0. X equals $30,000. That's what the son gets. Okay. Now that we got that, let's move on to the next one. I want to encourage you, now that we've done a practice round, to give this one a try on your own. Okay? When you're ready, let's go ahead and do it. The question says, there were 120 students on a field trip to Orlando. The ratio of boys to girls was 2 to 1. How many boys were there on the trip? So here it gives us a ratio of boys to girls. So 2 is boys, 1 is girls. Okay? And if I want to get my total, I add them up, and I know it's 3. 120 students on the field trip, so it gives us the total, and it asks us how many boys. So we're going to call it x, which means we're not going to use the girls number in this one. We're going to focus on boys and total because that's what the question gives us and it's asking us for. So the first fraction, remember, it comes from our ratio. So 2 boys out of 3 total is equal to x boys out of 120 total. Okay, let's cross multiply. 3 times x is 3x. 2 times 120, let's multiply. 0, 4, 2 is 240. I'm going to divide by 3 so I can isolate the x. 240 divided by 3. 3 goes into 24 8 times. 3 times 8 is 24. I have to bring down that 0. I'm done. X equals, bring down that 0. I'm done. X equals 80 boys. And that's our answer. Okay, I hope you got that. When you're ready, I'm going to move on to number 4. It says, the ratio of boys to girls in a classroom is 8 to 11. If there are a total of 24 boys in the classroom, then how many boys and girls are there altogether? If you want to give this one a try on your own, feel free to hit pause, try it, and then come back, and I'll do the explanation. When you're ready, I'll go ahead and show you how to do it now. So it says, ratio. Boys to girls, 8 to 11. So 8 is boys, 11 is girls, okay? If I want to add it, I get 19 total, okay? It tells us 24 boys in the classroom, and it asks us how many altogether. So, sorry, it's asking us for the total. So we're going to use boys, total, once again. Remember, our first fraction comes from our ratio. So 8 boys to 19 total is equal to 24 boys, and we don't know x total, right? So now let's cross multiply. 8 times x is 8x. 19 times 24, I don't know, but we're going to find out. 4 times 9 is 36, carry the 3. 4 times 1 is 4, plus 3 is 7. Placeholder 0. 2 times 9 is 18, carry the 1. 2 times 1 is 2, plus 1 is 3. So 6, 15, 456. So now we're going to divide by 8 on both sides so we can isolate the x. Let me make some space here. So 456 divided by 8. 8 goes into 45 5 times. 8 times 5 is 40. 45 minus 40 is 5. Now let's bring down that 6. 8 goes into 56 7 times. 8 times 7 is 56. 56 minus 56 is 0. So x equals 57. And there's my answer. 57 boys and girls. Okay, I hope you're getting it. When you're ready, I'm going to move on to the next one. It says, there are both marbles and stones in a large pot. The ratio of marbles to stones in a large pot is 3 to 5. If there are 51 marbles, then how many stones are there? So this one gives us a 3 to 5 ratio, marbles, stones. Okay? If we want to do the total, it would be 8. We don't know if we need it, but we're just going to put it there just in case. If there are 51 marbles, so it gives us 51 marbles. And what does it ask us for? The number of stones. Okay, so x stones. Do we use the total? No, we're going to focus marble, marble, stone, stone. Now let's set up our equation. Our first equation is 3 marbles over 5 stones. Why? Because it comes from our ratio. Our next one comes from our scenario, which is 51 marbles to x stones, because we don't know how many stones there are. So now we do 3 times x is 3x, and 5 times 51, we're going to solve it now, 5, 25. So I'm going to take a moment here. People might be wondering, what happens to these units when I multiply? I ignore them when I multiply, okay? I only put these units so I can make sure that marbles are aligned with marbles on the top and stones are aligned with stones on the bottom. That's it. That's all I use them for. And also to make sure that the units, are the same. But basically, it's the same thing. So I just want to let you know, because sometimes people are like, well, what happened? Why doesn't she use the marbles and the stones later? Because we don't need them. It's just for the setup. So 3 goes into 25 8 times. 3 times 8 is 24. 25 minus 24 is 1. Bring down the 5. 3 goes into 15 5 times. 3 times 5 is 15. 15 minus 15 is 0. There's nothing else to bring down. So x equals 85. And there's my answer, 85 stones. Okay, awesome. Now that we've done that, let's take a look at number 6 together. It says, the ratio of coins to bills in a bag is 2 to 5. If there are a total of 26 coins, then how many bills are there? So ratio 2 to 5. Coins is the first one. Bills is the second one. I'm going to add them up just in case to get my total. Total of 26 coins. How many bills? X bills. So we're not actually going to use our total. We're using coins to coins, bills to bills. My first fraction, 2 coins, 5 bills, comes from my ratio. My second fraction, 26 coins to x bills, comes from the other one. Now remember, we ignore our units and now we're just multiplying. 2 times x is 2x. 26 times 5, I don't know, let's figure it out. 5 times 6 is 30, carry the 3. 5 times 2 is 10, plus 3 is 13. So 130. And now we're going to do 130 divided by 2, because I'm going to divide by 2 on both sides so I can isolate the x. 2 goes into 13, 6 times. 2 times 6 is 12. 13 minus 12 is 1. 2 goes into 10 5 times. 2 times 5 is 10. 10 minus 10 is 0. There's nothing else to bring down. So x equals 65 bills. Okay, awesome. I hope you're getting the hang of this. Go ahead and give number 7 a try on your own. And just hit pause on this video. When you're done with it, or when you're ready, go ahead and watch the explanation now. So, it says, the ratio of black bags to blue bags is 5 to 3. If there are a total of 20 black bags, then how many blue bags are there? So, the ratio of black to blue is 5 to 3. 5 black bags, 3 blue bags. If I want to add them, I get an 8 total. Okay? If there are 20 black bags, 20 black, how many blue bags are there? Oh, look at that. We didn't need the total. We have it right here with our black, black, blue, blue. Our first fraction comes from our ratio, 5 black, 3 blue, is equal to 20 black bags, x blue bags. Now that we've set up our equation, we're going to cross multiply. 5 times x is 5x. 20 times 3 is 60. We're going to divide on both sides to isolate the x. And 60 divided by 5 is simply 12. 12 blue bags. Okay, when you're ready, let's move on to number 8. Okay, so let's do number 8. It says, there are both cars and trucks on a car dealer's lot, or on a dealer's lot, sorry. The ratio of trucks to cars is 2 to 9. Trucks to cars. If there are a total of 26 trucks, how many cars are there? So it gives us 26 trucks and asks us for cars. So 2 trucks to 9 cars. If we wanted the total, 11 total. But I'm pretty sure we don't need it because it gives us 26 trucks and it asks us for the cars. So now that we know this, we know we're going to do trucks to trucks, cars to cars. Our first fraction is 2 trucks to 9 cars. It comes from our ratio. Our second fraction is 26 trucks to an unknown number of cars. So let's cross multiply. 2 times x is 2x. 26 times 9, I don't know, let's find out. 9 times 6 is 54, carry the 5. 9 times 2 is 18, plus 5, 23. We're going to divide by 2. So we can isolate the x, and let's do 234 divided by 2. 2 goes into 2, 1 time. 2 minus 2 is 0, bring down the 3. 2 goes into 3, 1 time. 3 minus 2 is 1, bring down the 4. 2 goes into 14, 7 times. 2 times 7 is 14, 14 minus 14, 0. There's nothing else to bring down. X equals 117. And there we are. Okay. I hope this is getting easier for you. I hope you're understanding how to do it. Let's take a look at number 9. It says, the ratio of red ribbons to green ribbons is 1 to 3. If there are a total of 24 red ribbons, then how many green ribbons are there? So red to green, 1 red, 3 green. It gives us 24 red and it asks us how many green. If we wanted the total, it would give us 4, but we don't need it because we have red to red, green to green, and that's exactly what we're going to do. 1 red is to 3 green. Remember, our first fraction always comes from the ratio. 24 red to x green. Now, let's cross multiply. 1 times x, x. 24 times 3, 3 times 4 is 12, carry the 1. 3 times 2 is 6, plus 1 is 7. X equals 72 green ribbons. Okay, I hope you're getting it. When you're ready, let's do number 10. It says, the volume of water in 2 containers is in the ratio of 3 to 7. If the volume of the first container is 27 liters, what is the sum of the volume of the 2 containers? Okay, so container 1 to container 2, 3 to 7. So container 1, 3, container 2, 7. We add them up to get a total of 10. Okay? Then it says volume of the first container, so container 1 is 27. What is the sum of the volume of the 2 containers? Well, that just means the total. So we're looking for the total. So let's set up our fractions. We start with container 1, 10 total. We get this from our ratio. Container 1, x total. Okay, now that we have that, let's cross multiply. 3 times x is 3x. 27 times 10 is 270. I'm going to divide by 3 to isolate the x. Let's do 270 divided by 3. 3 goes into 27 9 times. 3 times 9 is 27, and 27 minus 27 is 0. But there's still 0, so we have to bring it down. 3 goes into 0 0 times. So x equals 90. 90 liters. Awesome. Okay, so I'm moving quickly because the questions are pretty straightforward. Feel free to go back and watch it again, pause, and think through any part that you don't understand. And if there's anything that you don't understand, you're always welcome to just leave a comment below, and I'd love to help you with those questions, okay? Number 11, it says, Brian, John, and Jack got paid a total of $400 for mowing neighborhood lawns. They split the money in the ratio of 2 to 3 to 5. How much less did Brian make than Jack? So here we have a ratio that's comparing 3 of them, okay? So we're going to treat it exactly the same. 2, 3, 5. Brian, John, and Jack. And my total, 2 plus 3 is 5 plus 5 is 10, okay? And this is my total. Now, what does it give me? It gives me what they all made together. So it gives me the total, 400. And it asks us, how much less did Brian make than Jack? This means we have to subtract, okay? We have to do Jack minus Brian. Okay, so let's solve for Jack and let's solve for Brian, and then we'll subtract them. So Jack, okay, 5 Jack to 10 total is equal to, I don't know how much Jack made out of the $400 total. Okay, let's cross multiply. 10x equals 400 times 5 is just 20, 2,000. I'm going to divide by 10. This eliminates a 0, and I find out that Jack made $200. So how much did Brian make? I'm going to erase this, and let's solve for Brian. So 2 Brian out of 10 total is equal to an unknown Brian out of 400 total. Cross multiply, 10 times x is 10x. 2 times 400 is 800. I'm going to divide by 10 on each side. I eliminate a 0, and I get x equals 80. So Brian made 80. So what's 200 minus 80? 0 minus 0 is 0. I can't do 0 minus 8, so I borrow, and this becomes a 10. 10 minus 8 is 2, and 1 minus 0 is 1. So what's the difference between Jack and Brian? $120. Okay, that one was a little bit different because we had to find 2 of them, and we had to subtract them from each other, but it's still the same concept. These kinds of questions, you really have to think through them and read the question carefully, okay? So let me make some space now. Let's move on to number 12. Number 12 says, in a classroom, there are students who wear glasses and others who do not wear glasses. The ratio of students who wear glasses to the total class is 3 to 5. So we have 3 to 5. And it tells us this is students who wear glasses. So I'm going to put glasses to the total class. So this is actually total. So if my 2 parts, or my parts all add up to the total, and my total is 5 and one of the parts is 3, the other part is 2, because 2 plus 3 is 5. And this is no glasses. Okay? So what else does the question say? 16 students who do not wear glasses. So 16 no glasses. And then it asks us how many students are in the class, or what's the total. So x total. Okay, now we have 2 no glasses, 16 no glasses, 5 total, x total. Let's set up our equations. Sorry, our fractions. 2 no glasses is 5 total is equal to 16 no glasses out of x total. Okay, let's cross multiply. 2 times x is 2x. 16 times 5, 30, carry the 3, 80. We're going to divide by 2 to eliminate the 2 and get the x by itself. 80 divided by 2 is 40, so there are 40 students in the class. Okay, I hope you got that. I'm moving on to number 13. It says, a school purchases desktop and laptop computers. If the order placed was for 1,200 computers, and has a ratio of 3 desktops to 9 laptop computers, how many laptops are in the order? So it gives us a ratio of 3 desk to 9 lap. 3 desk to 9 lap. If I add them up, this gives me 12 total. And it tells us that the total computers ordered were 1,200. So I am using that total. What does it ask us for? The number of laptops. So we're going to use the laptops, not the desktops. So lap, total. My first fraction comes from my ratio. So 9 laptops to 12 total is equal to x laptops, because we don't know how many there are, out of 1,200 total. Now that I've done that, I'm going to cross multiply. 12 times x is 12x. And 1,200 times 9, let's do it together. 0, 0, 9 times 2 is 18, carry the 1. 9 times 1 is 9, plus 1 is 10. So 1, 0, 8, 0, 0. We're going to now divide by 12, so we can isolate the x. And let's do that division problem over here. So 12 can't go into 10, but how many times does 12 go into 108? 9 times. 12 times 9 is 108. 0. I'm going to bring down each 0. 12 goes into 0. X equals 900. So my answer is 900 laptops. And there it is. Awesome. I'm going to go ahead and make some space. I hope you're getting this. When you're ready, let's do number 14. This is similar to a question we did earlier, so if you want to hit pause and try this question on your own before seeing the explanation, I highly encourage it. When you're ready, I'll begin. It says, Stacy, Jamie, and Karen order a pepperoni pizza to share. If the pizza has 8 slices and they share the pizza in a 1:1:2 ratio, how many slices of pizza will Karen eat? So here we go. Stacy, Jamie, Karen, 1:1:2. Remember, it's the order of the words. So Stacy, Jamie, Karen. That is a total of 4 slices. Okay. The pizza has 8 slices. So that's the total also. And we want to know Karen. So we're going to use the Karen, total. Our first fraction, 2 Karen, 4 total, comes from our ratio. And this is equal to unknown slices from Karen and 8 total slices from the pizza. So 4 times x is 4x. 2 times 8 is 16. We're going to divide by 4 on each side so we can isolate the x. 16 divided by 4 is just 4. So Karen ate 4 slices. Okay, so that was easy math. I hope you got it. When you're ready, let's do number 15. 15 is very similar to number 14, so I want you to give this one a try. So just hit pause and try it out. When you're ready, I'll show you how to do it. It says, Leandra, Genesis, and Alexandra decided to share a bag of jelly beans in a 2 to 3 to 5 ratio. If there are 30 jelly beans in the bag, how many jelly beans did Genesis eat? So 2, 3, 5. Leandra, Genesis, Alexandra. Let's add them. 2 plus 3 is 5 plus 5 is 10 total. And it says there are a total of 30 jelly beans in the bag. So we are using our total. And it wants to know Genesis, so x for Genesis. Okay, so now that we have all this, let's set up our equation. 3 Genesis, 10 total, is equal to an unknown Genesis, so x, over 30 total. And now that we've done that, let's cross multiply. 10 times x is 10x. 30 times 3 is 90. We're going to divide by 10 on both sides so we can isolate the x. And 90 divided by 10 is just 9. Genesis ate 9 jelly beans. Okay, that's it for our quiz. I hope you got it. Don't forget, you're welcome to leave a question in the comments below. Good luck. Hi, welcome. This is the video on solving averages for the arithmetic reasoning section. Let's go ahead and take a look at what a formula should look like for solving averages. So basically the way you find an average or mean is by adding all of the numbers given to you together and dividing by however many numbers there are. So it'll look something like this. The different numbers, so let's say you're given 3, 4, whatever amount of numbers, divided by the number of numbers there are, and that gives you your average, that equals your average. So before we start looking at the word problems, let's go ahead and take a look at what this looks like and practice to make sure we understand how to do it. So our first set of numbers is 35, 28, 32, 37, 31, and 29. Let's go ahead and find the average of these 6 numbers. How to solve this answer. I'm sure you did great on your own, but I just want to walk you through the steps to make sure you know how to do it. So the first step is to add them together, because remember, that's what our equation consists of. So we're adding 35 plus 28 plus 32 plus 37 plus 31 plus 29. And that'll give you 192. Okay? Now the next step in our equation is to divide by however many numbers there are. In the sequence, there are 6 numbers. That means that we will divide this by 6. The whole thing by 6. Well, we already added this up, right? And we divided by 6, so we can do that to the other side too. 192 divided by 6. Then we went ahead and we divided. So let's do that down here. 192. 6 goes into 19 3 times. 6 times 3 is 18. 19 minus 18 is 1. Bring down the 2, gives you 12. 6 goes into 12 2 times. 12 minus 12 is 0. So the average of these 6 numbers is 32. Let's go ahead and take a look at the next question. So our numbers this time are 1, 3, 8, 7, 3, 6, 9, and 2. Let's go ahead and find the average of these numbers. Welcome back. How'd it go? Don't worry, we're going to go over each step together to make sure you understand how to solve for averages before hitting those word problems. So the first step, remember, is to add up all of our numbers. So 1 plus 3 plus 8 plus 7 plus 3 plus 6 plus 9 plus 2. That adds up to 39. The next step is to divide that by however many numbers we have. And in this case, we have 8 numbers. So we're going to divide the entire thing by 8. And we do the same thing over here. Now when we do that, we go ahead and we divide it on our own. Let's do it down here, okay? So 39 divided by 8. 8 goes into 39 4 times. 8 times 4 is 32. So then 39 minus 32 is 7. Now, we have to move on to decimals because we have a remainder, and that's okay. What we do is we put a decimal down here, and we add a 0. And we put a decimal up here that lines up with a decimal inside this division problem. So we bring down the 0, and this makes 70. So 8 goes into 70 8 times. 8 times 8 is 64. This can keep going, but we're going to stop here because we want to keep this question simple. So you should have gotten something close to 4.8 in your answer.
So tell me, how'd it go? If you struggled with these questions, don't worry about it. Take a moment, go back, and try them again, and make sure you understand how to do them before moving on to the next question. But if you're ready, let's go. Let's look at the next question. Okay, you're practically an expert now. Let's take a look at what another question might look like. So this is not necessarily a word problem, but it's a little bit more challenging. I think you're ready for it. So the question is, if the average is 14, what is the missing number in the sequence? 12, 15, 17, 14, 18, 11, and x. All right, great. How'd it go? Hopefully it went well. If not, don't panic. I know this is a bit complicated, but we're going to go through this problem step by step to make sure you understand how to do it. So here we go. I went ahead and put everything into the equation for you. So our average goes on the other side of the equal sign. And the question says that the average is 14. So I went ahead and put that on this side of the equal sign. I put all of our givens, so all the numbers it gives us in the sequence, on this side, and I went ahead and I divided it by the number that there is. So this part might be a little tricky because one of them is an x. So we have 12, 15, 17, 14, 18, 11, x. X is our unknown. It's the one that we don't know what the answer is, and that's what we're solving for. But when we're counting however many there are, we have to count that as one of the numbers. So make sure that you divide it by 7, okay? So here we have 1, 2, 3, 4, 5, 6, 7 with our x, and that's why there's a 7 down here. Now, to be able to solve for this, we need to isolate the x. And to do that, we have to, first of all, get rid of this fraction. It's messy. We don't want this. So we're going to multiply by 7. Whatever we do to one side of the equal sign, we do to the other. So this cancels out over here, and we have 14 times 7. Let's just do that real quick. 7 times 4 is 28. We carry the 2. 7 times 1 is 7, plus 2 is 9. So we got 98, all right? Now, when we add this up over here, actually, let's do this. Let's go ahead and rewrite our question so it's easier. So we have 98 is equal to 12 plus 15 plus 17 plus 14 plus 18 plus 11, plus x. Now this is messy. Let's get rid of this. And we do that by adding them up. When we add that number up, we get 87. So let's rewrite our question. 98 equals 87 plus x. Are you with me so far? Now, what do you think we have to do next to solve for this x? Well, the 87 is added to it, so what we have to do is subtract. So we minus 87 from both sides, and we're left with 11. The missing number here is 11. Okay, make sure you look over your notes, look at what you did wrong if you did get it wrong, and make sure you understand before you move on to the next question. If you're ready, let's go. Let's take a look at some word problems. Jerry scored 85, 92, 67, and 78 on 4 of his exams in his mathematics class. What is his average score on 4 exams? First thing that we need to do is add these up. So I have the numbers written here. Let's go ahead and add these up. When we add these numbers up, we get 322. According to our equation, the next thing we need to do is divide by the number there are. Okay, so there are 4 exam scores here. So we're going to divide this whole thing by 4, which means we're dividing this by 4. Let's go ahead and divide that by 4 together. So 4 into 322. 4 goes into 32 8 times. Real easy, right? 4 times 8 is 32. 32 minus 32 is 0. We bring down that 2. 4 goes into 2 0 times. People get tricked up on this one, but it's 0 times. So we put a 0 on the top, okay? 4 times 0, 0. 2 minus 0, oops, sorry. It's not 0, it's actually 2. So 2 minus 0 is 2, sorry about that. So now we go ahead and we add a decimal point because we want to keep going. We're not done. We have this number left over. So we always put a decimal point in the bottom and the top. Make sure that they're aligned with each other. We add a 0 here and we bring it down. This becomes 20. Hope you can see that, but this becomes 20. So 4 goes into 20 5 times. 4 times 5 is 20, and 20 minus 20 is 0. We are finished. So the average of the 4 exams is 80.5. How did you do? If you didn't get this one, it's okay. Go over your notes to see what you did and make sure that you make any corrections before you move on to the next question. Let's go. Let's do this. Great. Now let's go ahead and take a look at problem 2. Susan scored 86, 77, 69, 90, and 72 on 5 of her history quizzes. If she can drop the low score, what will her average score be on her quizzes? Let's take a look at how to break down this question. So if you got a little confused, don't worry about it. Just make sure you follow along how to break down the question and go back and look at your notes to see what you did wrong, okay? So let's note something really important about this question. The first thing you need to know is that the problem says you can drop the lowest score. So if Susan gets to drop her lowest score and you wrote out all the scores like this, you need to cross out the number 69, okay? So when we add this up, we're not including the number 69. So if you add these 4 numbers up, you get 325, okay? So now this, again, it's a little tricky, but because she got to drop her lowest score, we only have 4 scores left. So when we divide, we're not dividing by 5 anymore, we're actually dividing by 4, okay? So that means 325 needs to be divided by 4. Let's go ahead and do that one together. So 4 into 325. 4 goes into 32 8 times. 4 times 8 is 32. 32 minus 32 is 0. We go ahead and we bring down that 5. 4 goes into 5 1 time. 4 times 1 is 4. 5 minus 4 is 1. We have to go into decimals again. Not a problem. Add a decimal here and one that's lined up with it on the top and add a 0. So we bring down that 0 to give us 10. 4 goes into 10 2 times. 4 times 2 is 8. 10 minus 8 is 2. We can keep going, but let's not make this complicated. We're left with 81.2. If you got something near that, then you did it right. If you didn't, like I said before, go back and check to see where in your notes you went wrong and break this down step by step. If you got confused with the crossing out of the 69, make sure you're paying attention to what the question is asking you for, so you don't miss those essential little pieces that will help you get the right answer, okay? If you're ready, let's go ahead and move on to the next question. Chris scored 76, 88, and 70 on the last two exams in geography class. What is the lowest score he can get on his fourth exam in order for his average to be higher than 80? First of all, it's asking for an unknown. So I went ahead and wrote up here the three scores he already got, okay? So 76, 88, and 70. Now it's asking us to add a fourth score that we don't know about. Well, what do we call those in math? When we have an unknown, we call it a variable, and we usually call it x. So let's write that here. So plus x. That is our fourth score. We're going to divide this by 4 because we always count the variable when we have one, even if it's not technically a number, okay? And we know that he wants to have an average of 80 or higher. So the least that he needs to get is an 80. So let's go ahead and put that in here. Now, to be able to solve for x, we need to isolate the x, okay? So let's go ahead and multiply by 4 because this looks complicated and we want to simplify it, okay? So we multiply by 4, and that gets rid of that over here. We have 80 times 4 is 320. The next thing we want to do is we want to go ahead and add these three scores up. When we do that, we get 234. Plus x, don't forget your x because that's important, and that is equal to 320. Now, to finish isolating this x, the next thing we need to do is we need to subtract it. Well, not the x, the 234, just to be clear. So we're going to subtract that from over here, and that cancels out. And we're going to subtract it from over here. Well, we borrow, and this becomes 10. 10 minus 4 is 6, 11 minus 3 is 8, and 2 minus 2 is 0. So, in order to score at least an 80 in all of his exams as his average, Chris needs to score an 86 on his fourth exam. Go ahead and take a look at what we did here and take some notes and look to see what you might have done wrong if you did do something wrong. If you got it right, awesome, congratulations, you're doing great. Make sure that you continue practicing, use all the resources we have available for you in this program, and any resource that you can find online. The important thing is that you're getting ready for the ASVAB. So if you have any questions, make sure to email us and continue practicing. Thank you for watching and good luck.